Part 1, show the following in log form. This here is the base and this is the log. So we go log to base 2 of 16 equals 4. In part B, we've got log to base 3 of 81 equals 4. Part C, we have log to base 4 of 1 equals 0. Anything log of 1, no matter what base it is, will be equal to 0. So over here, part D, we have log of base 10 0.001 equals -3. Then we've got log to base B of A equals K. And finally we have log to base 2 of 1 on 8 equals -3. Okay, so this one is simple again, but it's just the other way around. So this time we have 5 to the 2 is equal to 25. So 5 squared equals 25. Then we have 4 to the -1 equals 1 on 4. So again, it's this number to this number equals that number. Over here it's 10 to the 4 equals 10,000. And this one, it is 3 to the 4 equals 81. Then 5 to the 5 equals 3,125. So that's all just straightforward. All we've done is rearranged it from log form to indicial form. Okay, so if we're not using our calculator for these, we start by looking at what the base is. So we want to see if we keep multiplying this base by itself, will we finally get to 32, and what power will get to that value. So if we multiply 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, we realise that 2 to the power of 5 equals 32. So we can write this as log to the base 2 of 2 to the 5, and then we can bring the 5 out the front. So that equals 5 log to base 2 of 2. Now the other logarithm rule is that when you take the logarithm of the base, that equals 1. So that actually equals 5 times 1 equals 5. Now this one, part B, log 3 of 81. Now if we multiply 3 times 3 is 9, times 3 is 27, times 3 gives you 81. So 3 to the power 4 equals 81. So what we can do now is we can go log 3 of 3 to the power 4. And then that equals, because of this same power rule that we used in this one, bring that over the front, so 4 log 3, 3. And again, this is equal to 1. So that answer equals 4. Now part C, how many times do we multiply 5 times itself to get 625? So 5 times 5 is 25, times 5 is 125, times 5 again, and that gives you 625. So again, 5 to the 4 is equal to 625. So we've got log 5 of 5 to the 4, and that equals 4 log 5 of 5, which equals 4 times 1 equals 4. Part D. So this one's slightly different because it's the denominator. But we worked out earlier that 2 to the 5 over here, 2 to the 5 is 32. In this case it's on the bottom. So it's log 2 of 2 to the -5. Because the negative makes it so that it's actually 1 on 2 to the 5. and that equals negative 5 log 2 of 2, which gives you negative 5. Part E, this one's pretty simple, so it's 10 squared is 100, so log, that equals log of 10 squared equals 2 log 10 of 10 equals 2. And then this one is log to base 10 of 10 to the negative 4, because 10 to the negative 4 is like saying 1 times 10 to the negative 4, so 1, 2, 3, 4, that puts the decimal in that position. And that equals negative 4 log 10 of 10, which equals negative 4. Okay, log 2 of 0.25. We know that 0.25 is a quarter, or you could say, okay, let's try and work it out. 25 on 100 because 25 divided by 100 puts the decimal there. Then we bring it down to its lowest form, 1 on 4. So that equals log to base 2 of 1 on 4. And that equals log to base 2 of 1 on 2 squared. And that's the same as saying log of base 2 of 2 to the negative 2 equals negative 2 log 2 of 2 equals negative 2. Okay, part H, first we've got to work out how many times 3 might multiply to give that, if in fact it does give that. So we've got 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, times 3 is 729. So we've got 1, 2, 3, 4, 5, 6. So it's 3 to the power of 6 equals 729. Now we can rewrite this as log to base 3 of 3 to the 6. And that equals 6 log 3 equals 6, because log of its own base is equal to 1. Okay, with this one, so 2 to the 6 is 64. You can work that out by just continually multiplying until you've got it. So because it's the denominator here, it's log 2 of 1 on 2 to the 6, which equals log 2 of 2 to the negative 6. And that equals negative 6 log of 2 to the base 2, which is 1, and that equals negative 6.